Hi everyone, and welcome back to our Imagine a Cup Junior webinar. My name is Corey, and with me today is Amanda.
Hi everyone.
So what are we going to be covering today? Well, today we are actually going to be looking at design thinking and machine learning, okay? And if we think back to last week's webinar, we covered the fundamentals of AI. And in the fundamentals of AI, we learned that it actually has three components. It has machine learning, data, and algorithms, okay? And today we're going to be looking at machine learning and data in more depth. But let's start with design thinking. And what exactly is design thinking? Well, design thinking is actually going to be hugely important to your project. And in a nutshell, all design thinking actually is just a process for creative problem solving, okay? So it allows us to understand the problem that we have and that we're trying to solve, how it will affect other people, and what available solutions are there out there for us. And it's broken into 5 stages. So the first stage is empathize. And empathy allows us to just gain an understanding of the problem, okay, that we're trying to solve. It means that you just put aside your own assumptions about the world and actually gain a real insight into other people and their needs. The second stage then is define. And during this stage, we tend to gather all of the information that we've learned about the problem in stage 1. We then look closely at that information and that data, and we define the problem and try to identify what information we have about that problem so far. We then move on to ideate, and at this stage, designers are usually ready to generate ideas, okay? They have a solid background of stage 1 and 2, and they're ready to think outside the box, okay? They're ready to look for alternative ways to view a problem and identify innovative and creative solutions to that problem. Then at stage 4, we prototype. And this is an experimental phase. And the aim of this phase is just to identify the best possible solutions to the problem that you've been discussing and learning about. Okay, and design teams will usually produce a number of really inexpensive and scaled down versions of that product. And then finally, we test. Okay, but for your project, you're only going to be asked to focus on the first 3 stages, okay? You're going to be asked to empathize. So you're going to be asked to look for a problem and try to actually understand that problem using empathy. You're then going to be asked to define, which means just gather data and information on it. And then finally, you're going to be asked to ideate. So come up with ideas on how to solve this problem. But all problems have boundaries and limitations, okay? So this is why last week, myself and Amanda asked you to write down 10 ideas. And you're probably thinking, 10, why are you making us do 10? But the reason for that is because not every problem is going to be able to be solved, okay? It might not be realistic or it might not be achievable in this time. So it's important that you have 10 ideas written down that you can actually look through and think, okay, well, this one's definitely achievable and I can do this one. And by this stage, you know that your project is going to be focusing on AI for good, okay? And there's 4 pillars when we talk about AI for good. We have AI for Earth, AI for cultural heritage, AI for accessibility, and AI for humanitarian action. Now, with your project, okay, you're going to pick one of these pillars. And I'm going to pop into the chat now the link that you can go to actually learn about these pillars in more depth, okay? So it's aka.ms/AI for good, okay? So we're going to pop that into the chat now if you want to go and look at any of them in more depth. Your project is going to be marked or graded on these 5 parts. So innovation, has it been done before, okay? Buildability, is it realistic and can this project actually be built out? Impact, who is it impacting and is it having a positive impact on a person or changing the world in some way? Presentation, and then ethics. And don't worry too much about ethics because we will be delving into that a little bit further down the road, okay, in other webinars. So now that we know what design thinking is, we have a bit of an understanding of design thinking and how it's actually going to, impact our project. Let's have a look at machine learning. Now, what I want to do now is I want to just watch this video really quickly, and then afterwards we can discuss what's going on. Okay, so basically what that video is explaining to us is that there's a camera on top of a rooftop in New York, right? So on top of Sister City Hotel, I think it said, in New York City, okay? And this is really cool because the camera that's on top of the roof, okay, checks or has a look at what's going on outside, and then it actually changes the music that's in the lobby of that hotel. And it does this using AI. So for example, that camera can learn, it's been learning bird formations and cloud patterns and different types of aircraft and seasonal changes. And once the camera looks out onto the rooftop, it can see and it can recognize what's going on outside and then just changes the music accordingly. And I just think that's fascinating. I just think that's like mind blowing. That's the maddest thing ever. And it's so, so cool. So machine learning can do a lot of things, okay? And machine learning is how AI actually learns. It learns from experience, it learns from people, and it learns from data, okay? So the more experience it gets, the more people interact with it, and the more data we feed it, the more it can learn and the more it can pinpoint actual problems. So we have two phases when it comes to machine learning. We have phase one, and in phase one, machine learning just actually looks and analyzes data, okay? But with phase two, what happens is based on the data that it was provided, it actually learns how to make better decisions in the future. And the whole primary goal of machine learning is to allow the machine to learn automatically without ever having to have any human intervention or interference. And the reason we use machine learning is for a few reasons, but one of them is to automate mundane or very boring tasks, okay? Machines can actually learn how to think for themselves and make smarter decisions. We can also use it for like coding, for example. Some code can be really, really complex, too complex for humans. So what we can do is we can actually give it to a machine to learn. And traditionally with programming, we would take and input data into a program and it would give us an output, okay? But with machine learning, it takes data, it takes previous output, so previous experience, and then it gives us an output. And we use machine learning every single day. So we used this example last week, didn't we, Amanda, with Alexa and voice assistants and stuff like that.
Yeah, exactly.
But let's have a look at search engines now, for example. So anytime that we use a search engine, you might type in what is there and it prompts the weather like in Dublin today. Okay, so this is another example of us as humans interacting with machine learning and AI every single day. But what's important to recognize is that we need data for machines to learn, okay? We need to be inputting data and data sets into machines all the time because that's how they learn, okay? Let's take our example last week. So last week we looked at this data resource, which is all the current COVID-19 cases in Ireland. And we use this data. And from this, we can make decisions based on when the curve might flatten or when we might peak, okay? And data sets are so important, probably now more than ever, because the more data that we're getting, it's actually helping there. Well, we're hoping that it will help slow the spread of coronavirus, okay? So for example, with machine learning, right, how it uses the data that we're giving it is it inputs it. So we input the data into a machine and it looks for relationships and patterns and then gives us an output. So if we take, for example, COVID, right? So sticking with that example, that's new, okay? And this is the problem that we're facing. It's new, we've never had it before. And like the World Health Organization are rushing and they're trying to get as much data as they can as possible on this so that we can figure out patterns and relationships. So why is it that over 70s are getting it, or why is it that people with underlying health conditions? So the more data we have on this, the better informed decisions that we can make, okay? So maybe at the start, they recognize the pattern with over 70s, and they're able to say, well, people who are over 70 are actually getting this at a higher rate than people under 70, okay? So that was the machine recognizing a pattern, and then governing bodies like our government were able to say, okay, well, we're going to allow the over 70s to cocoon for a certain amount of time, okay? That wouldn't have been possible without all of this data. So there is multiple different types of data sets when we're talking about data, okay? And we looked at image processing, sentiment analysis, and speech recognition last week. So let's just quickly recap over them before we move on to the newer ones. So image processing, we looked at seeing AI, didn't we, Amanda? With
yeah, really cool.
This man here who was visually impaired. So what he was able to do was wear these really cool tech glasses and take photos of what the world is like around him. And then the technology was able to feed back him that maybe there was a girl playing frisbee or a young man walking their dog. So that's really cool. That's image processing. And then we have sentiment analysis, and we use an example for this. We said Ireland is going to do amazing in the Imagine Cup Junior competition, and it was able to pick out that that was positive, okay, because it's looking at negative, neutral, and positive words, and then it's taken out what it thinks that sentence is from that. And then lastly, we looked at speech recognition, which is our good old Cortana and Siri and Alexa. But this week, we want to look at 3 more. And the first one is natural language processing. And all that is basically teaching machines how to understand how humans speak, okay? Because you might notice I say okay or like or all right a lot because I'm not a robot, okay? I'm a human, and that's just how I naturally speak. So what we want to do is we actually want machines to be able to understand that. So I'm going to use a demo now, and I'd like everyone to do it with me. So I'm going to pop into my browser, and I'm going to type in the following link, okay? So you can follow me at home, or you can go to this link and pause me and do it yourself. But we're going to go to aidemos.microsoft.com, okay? And we are going to do language understanding. So let's try this out. Okay, so it's Meet Louis, and all Louis stands for is Language Understanding Intelligence Service. And I'm going to see it in action. So let's demo this. And remember, pausing if you want to go ahead and try this yourself before I do it. So we have the house here, and it has some lights on, okay? And I'm just going to say, right, well, I want to turn off all of these lights, okay? So I'm going to say turn off all of the lights. And let's see if it does this. Woo! Ew. Okay, that's pretty cool, I think. Yeah. Now, you might see, well, it's pretty dark, but Amanda, can you see there's someone up there reading a book?
Yeah.
Top left. So I'm going to say, I want to read my book. And let's see if this just turns on the lights in that room. It does. Okay, it actually turns them on a little bit. Yeah, but I probably need more. So I'm going to say, I'm going to type in, I need more light to read my book. And it should get a little bit brighter. Aha, and I could keep going all day until the lights are on. But that's pretty cool. But there's something else, Amanda, you showed me before. I was like, this is so cool.
Yeah, we can say lots of things about the whole house, can't we? But
yeah, we can turn on out
one that maybe people don't have at home is call Batman.
Yeah, call Batman. Let's see if what happens when we type this in. Bat signal.
Bat signal. Yeah.
Okay, and that's really cool. So pause me and try out a few different things, but remember, it's not going to be right all the time, is it, Amanda?
No, because it's only a demo, and you know, if a company probably was going to use this language understanding system, they would really train it up according to their needs, and it would be very, very well trained. So, but it's definitely worth to play around at home because it gives you a good idea of how you can type something in the way you would say it, and the machine responds.
Yeah, it's pretty cool. So that's natural language processing, okay? So now we're going to have a look at video processing. And we can see from this image here, okay, that this video is showing a lot of people trying to get on this bus, okay? And what the machine can do there is it can recognize, okay, there's too many people and there's not enough seats. So maybe what we can do is we can either put on 2 buses or we can put on a double-decker bus, because at this specific time at this bus stop, there's too many people and there's not enough service available. Okay, and there's a really cool example of this on AI demos when we talk about video processing, and I think it is my favorite. So I'm going to go back into the internet. And let's go to aidemos.microsoft.com again, okay? So just the same link. And this time, I am going to go down to Video Indexer. So I would like you to do this with me at home, okay? So pause me if you want to go off and explore this on your own, or follow me now. So let's try out Video Indexer. And I'm going to go with the first video, okay? Now, coolest thing, I think, is that it actually picks out the people that are in the video, okay? So it's telling me here there's 2 people in the video. There's Satya, who's the Microsoft CEO, and then there is Sam George, okay? So let's say I am a journalist, okay? And this is how this can be really, really beneficial in real life, okay? Let's say I'm a journalist and I'm writing for an Irish newspaper. We all know at this stage that there's usually government briefings around 6 o'clock every day. Okay, so I'm a journalist and I'm writing an article about education, and I want to know everything that's going on to do with COVID and education. Okay, I might have here, I might have, you know, the Minister for Health, I might have Simon Harris, Tony Houlihan, I might have Leo, and then I'll have Joe McHugh. Okay, so if I'm writing something about education, I'm probably going to just want to see wherever the Minister for Education is. Okay, so I'll click on their face and then I can watch all the times that they speak. Okay, but even cooler then, so that's people, so that's picking people out of videos. We can pick out key topics. So the Minister for Education might not be the only person who actually references education in those briefings at 6 o'clock, okay? Leo might mention education, the Minister for Health might mention education. So what I can do is I can look at the amount of topics that were actually discussed. So it might be cocooning, hairdressers, over 70s, anything that was talked about that evening. And then I might go, oh, education, that's what I'm after. And then if I click on, let's say, this said education, I can see, oh, it appeared actually 2 times for a total of 2% of the video. So I can click there and see what other people had to say about education. I just think that honestly is mind blowing, to be honest. If, like, as a real life example, can you just imagine the amount of time that would save a journalist?
Yeah, brilliant.
There is one more part of data sets, okay? So there are 6 in total and we've talked about 5. And the last one is the Internet of Things, and Amanda is actually going to take you through that now.
Yeah, perfect, guys. Okay, so thanks, Corey. Yeah, so we've done a couple now. We've gotten as far as the final one we want to talk about, which is the Internet of Things. And with something like the Internet of Things, the data set tends to be pretty large, because what the Internet of Things is basically lots of connected devices and sensors. So sensors may be placed around your house, for example, that are all connected maybe back to a main computer, okay? So those sensors are picking up data and information and sending them maybe continuously back to this other location where it's going to be stored. That's going to store and I suppose grow in information all the time. So when we think about a house, the best example is probably something like a smart heating system or a thermostat system, where you might have temperature sensors in every single room of your house, and they are sending temperature information back to this main computer, the main heating system, which is the main computer, and it's monitoring it. And it knows that if the temperature maybe goes to a certain level, so for example, maybe over 21 or 22, depending on what you've set it at, then the heating will switch off completely. Or maybe in one part of the house it's warmer because the sun is coming in, but in another part of the house it's not as warm. So the heat needs to be on in the back rooms because the sun isn't there, or whatever it is. So it's able to continuously use data to monitor this and then inform the decisions, okay, which is really, really interesting. Now that's an example of consumer Internet of Things. So like what we would use in our houses is a consumer way of using it. Whereas the one I'm going to show you in a video now in a second is what we call industry Internet of Things, because we work with companies all over the world that are using this idea of placing sensors around their business or their locations to inform their decisions. And if you think about it, that's going to be a lot of data, a lot of information that they have to process and analyze. Okay, so that's going to be the industry Internet of Things. The idea with this is that companies can get so much information, and it will be a lot, and we'll give you a video example now in a second, but it will help them analyze what's happening with their company. It will help them predict things for the future, and it will help them even respond before something might happen, okay, or cause a problem. So let's have a look at a video example here of a company that's using this idea of sensors and the Internet of Things.
One of the things that we like to say to people is you don't have to live in a concrete jungle. The idea and the hope was to create a product line where you could bring nature back into, honestly, every environment.
Our first generation of these products relied on the maintenance companies to determine if there was any problem with the irrigation system. We had no eyes or ears on that product. So I reached out to Cradlepoint knowing that they had routers that could probably solve all my needs for bringing the data from our sensors back to the dashboard, at least for analysis. And frankly, I was worried a lot about security.
Sage Green Life had a problem. They were looking to provide connectivity to the vital infrastructure within their beautiful living walls.
Cradlepoint introduced us to the team at Microsoft and got us up and running in days. And we're now monitoring the irrigation system.
By combining IoT Central and Cradlepoint, we've been able to deliver that end-to-end security solution that Sage Green Life really requires.
And it took almost no training to be able to build a dashboard that watched our sensors and reported alerts. So on one dashboard, I have everything I need to know about how the wall is behaving. And if there's a problem, I know everything about the customer and how to go out and get it repaired.
Once they have a connected wall, it opens up a whole series of possibilities of new services and capabilities. And it's all because they now have the connectivity and the ability to gain whole new insights through the relationship they have with Cradlepoint and our integration with Azure IoT Central.
With this IoT platform, we're going to make this product by far the most reliable living wall system on the planet.
Okay, so what you're seeing there is a company called Sage Green Life. And Sage Green Life are using the Internet of Things to inform their company's decisions. So they're putting living plants on the walls of companies. And Corey, can you hear me okay?
Yep, I can hear you.
Perfect. I'm just making sure. So they're putting sensors on these living walls or these living plant walls. And what that's doing is it's sending information back to them about how the plants are performing. Are they okay? Are they do they have the right moisture levels in the soil for the plant? Is the irrigation system even working? And what that can mean is it can actually let them know if something is going to go wrong. So for example, say on one of those walls, the irrigation system, the system that's watering the plant stops working. It will actually use a sensor to pick up on that and alert Sage Green Life before there's an issue. So before their customer rings them and says, all the plants are dying on the wall, they're going to know there was an issue, that there wasn't water before that even occurs, which is really, really useful. Now, with the Internet of Things, the most important part of this is that we get a huge amount of raw data. So if you think about Sage Green Life, they have not just one or two living walls, they have lots of customers with lots of this product all over. So there's lots of information coming back all of the time to them and their company. And they need to figure out a way that they can process this information. So first of all, they need to make sure that it's in the right format. So for example, that it's been converted into a way that the computer can understand. Next, they need to make sure that they can store a backup for this in the cloud so that they can go back and reference that if they need. Thirdly, they need to actually see, is there anything in that data set that they don't need, that's repetitive or unwanted, and they could clean the data set. And then lastly, what they might do is they might actually add to the data set. So what they might do is say find information about that plant and how best that plant performs, input that in with the data set so that it actually helps the machine learn even more about it. So it can be really, really useful for a company like Sage Green Life and tons of companies across the world to have this kind of real-time information to process. Now, when that's processed, it results in what you've seen in the video there, which is kind of like Sage Green Life having these nice pie charts where they can actually analyze the data in a really easy way. So we have analytics that we can use for this. Now, depending on what you're analyzing, so some data is analyzed with prescriptive analytics, you can see there, for example, because you might want to, you might first of all have a certain type of data set, and secondly, you might want to gauge something in a certain area, okay? So there's lots of types of analytics and we're not going to delve into them all, but what I would reference is, or give you an example of, is the time series analytics one there. So time series analytics is when the computer or the sensors, apologies, not the computer, the sensors are picking up information over time and feeding that back to the computer. And what that means is if we're looking at something like weather patterns, for example, you know, a short space of time isn't going to be enough for us to really learn and understand about things like weather patterns. So what we need to do is really analyze and study them with sensors over a longer period of time. And then that will help us make really informed decisions about that. What's really extra important with all of this, what we're talking about, because we've done all of our data sets, and we'll do a recap in a second, because I know that was a lot of information. But with every single type of data set we just talked about, Corey and myself, you need to make sure that those data sets are reliable. So if you think about it, what we're basically trying to explain to you up to this point is that data sets are what are being used most of the time to create these machine learning models. Now think about this. What if that data set is inaccurate or completely unreliable or maybe completely false? You're training a model on something that is inaccurate, and therefore your whole model and your whole product potentially could be inaccurate too. So when you guys are thinking about your AI for Good challenge and you're thinking about, you've come up with an idea of maybe we could design this, think about the type of data that's going to be used and how you could source that and make sure that it's reliable and hasn't been altered, because that's really, really important moving forwards. Okay, we're going to take a breath for a second and pause. And can we think about what we've learned so far? So what we're trying to get across here is that with machine learning models, we need to utilize data sets and make sure those data sets are accurate and reliable. And the types of data sets we've now covered up to this point, and we've given demos of both last week and this week, are we've had image processing. So we've looked at vision and image processing. We've looked at speech recognition. We've looked at, what else did we cover last week, Corey?
We've looked at vision processing.
Yeah, vision processing. We have natural language processing as well. So we did that one today.
Sentiment analysis.
Sentiment analysis, thank you. Yeah, sentiment analysis, thank you. We looked at natural language processing today. We looked at video indexing today, and now we've looked at the Internet of Things. So we've done a huge amount of work on that. Okay, so well done everyone at this point. What we want to do now is give you another demo of something that we use very, very frequently, okay, in kind of our everyday lives. And you might not even notice that you're engaging with this, but you are, and it's called a bot, okay? And we're going to delve into this idea a little bit more, understand what a bot is. We're going to do a demo with you again, so we're going to get you to jump into your browser and try this out with us as well. And then we're going to really think about what's behind this, what is making a bot work, and where does this fit in with the idea of machine learning. So first of all, what is a bot? So a bot is an application designed to perform an automated task. So a really simple example of this is the ones we've used already with our speech recognition. So things like Cortana that we have in Microsoft, our voice assistant, or Siri with Apple, or maybe Alexa, where you can actually give them a specific command and they are programmed to perform with that command. So you would say, for example, Cortana, set me a timer for 1 hour, and that's what will happen, okay? Because they can be designed to react to those tasks you've asked them to do. We are going to specifically look at a chatbot now. So a chatbot is programmed to converse with a human to help them accomplish a task. So think about it, it's all very conversational. Sometimes we use these when we're ordering takeaway. Sometimes we use them to help us send an email. Sometimes we use them to give us information, maybe banking information if we go onto our online banking. So little windows pop up and they're little chat windows and we can try them out. So they're really, really useful for us to kind of get information really fast. And for companies, they're really useful because it means that they can have all of these created already, ready to go to assist with maybe tons of customer queries all at once. Okay, so let's hop into an example of this. We're going to get you to do this with us again, kind of like Corey earlier. So when I go to the web page, I'll demo it for you if you want, and then you can pause the webinar and you can just play around with it yourself. So I'm going to go to my browser. And we're going to go to our website that I'm using, which is aka.ms/healthbot. So aka.ms/healthbot. And I'm going to go there. Okay, so we have Microsoft Healthcare Bot. So here we go. And basically you can see bringing conversational AI to healthcare. So the whole point of the chatbots is that it feels natural, kind of like the natural language processing we talked about earlier with Corey. It feels natural. It feels like you are talking to someone. It shouldn't feel like you're talking to a machine, okay? So I'm going to go down here and you can see there's two different options. And I'm going to click try a demo of an example. Okay, so I'm going to go to that one. Give it a second, it'll load up. Now, if you want to watch me do it, and then as I said, you can pause and you can try it out yourselves, okay? So type your message. I'm going to just type hi, because, you know, typically if this window popped up for me, that would be the first thing I would type, wondering what am I doing here, okay? Hi, how can I help? So that's what they're writing back to me. Okay, I'm going to say I have a headache. I don't, by the way, but we're pretending here. Okay, please enter your age. I'm going to lie. And I'm going to say that I'm 21, which I'm not. Please specify your gender. So I'll go female. And you can see how fast this is, okay? I'm not waiting long. I'm not sitting back waiting for it. It's really quick. So as a customer, I'm getting very quick answers here, which would kind of help me and kind of comfort me to know that I'm getting somewhere. How much does it hurt? How bad is the headache? So I might say moderate, it's 4 to 6, interferes with work or school. When did this happen? Now, I could keep clicking and it will keep going on and keep working towards to get to a point where it can give me some sort of advice or a solution. If you guys want to pause at home now and try this out yourselves, okay, go to the web address we just did, and I think we've popped it into the Q&A as well, and play around and just try and identify what's happening here. I'm typing a message, the chatbot is responding, and how does it work? Okay, what is exactly happening? Because maybe one of your solutions in your project is going to be something involving a chatbot. You never know. So it's good to kind of really think about what is happening. And I'm going to show you the behind the scenes of it now, okay? But try it out first and then come back and replay the webinar, continue with us, and you'll hear what is behind this then, okay? So we're going to hop back in and we're going to look at this, okay? Now, So behind all of this, I want us to understand when I was typing to the health bot there, what exactly is happening, because all I'm seeing is what I type and what the chat bot responds with. Yeah. So yes, I type a message. So I type a piece of text and I then pass it into the chat bot. Okay. What's really important to understand is our machine won't understand the basic text that I've just written as a user, as a customer, okay? So that has to be actually converted into a format, okay, that the machine understands. You might see the ones and zeros here. Myself and Corey are a big fan of these, or jokes about these in particular. So it's our binary code. So just basically in a format that the machine can really understand, okay? So we talk in a normal language, but then the chatbot converts it into a language the machine can understand. And then what it does is it cross-checks it in with the cloud. So it has all of this stored information in the cloud that it can now cross-check what we have said against, okay? Now this cloud-based search is based on tons of work that's been done. You see all of these other icons that are feeding into that. We're not going to go into them, but basically they've prepped the cloud for these queries. So our query goes in, okay? It hopefully finds some sort of a match or some sort of an answer it can go back with, and it sends it back. Now, when it sends it back, guys, it's going to be still in the machine's language. So not a language that I or you will understand if it comes back to us as a user. So what will happen is in the machine's language, it will get converted back into natural language by one of our cognitive services that we talked about last week. And that will go from the bot back to us, which is what we've seen at the end when the chatbot said, please enter your age, for example. Now, what's fascinating is how quick this is happening, because you've seen there when I was doing the help bot, or even when you used it at home, that this is pretty much straight away, isn't it, Corey? It's like immediate. Yeah. So I type in my query, and straight away I'm getting all these questions back, or all these answers back, or these categories back that I have to select. So it's really, really fast. And that's because when obviously they were trying to develop these bots, they really know what they're looking for. They know the content that this user should be asking about, or what this person should be trying to find information about, okay? So that gives us the idea of what you need to do. So if you were building a bot, so if I decided I want to build a bot about DreamSpace HomeSpace, for example, I know that there's a certain amount of content to do with DreamSpace HomeSpace. I know that there's probably tons of different types of questions people could ask. So what I would do is, first of all, I would look at what's my requirements, or what's our requirements to build out this bot. What do we want for the user to find out? What information do we need to include? And that will feed into our spec. So basically we'll make up a specification or a spec document that says, this is what this bot's going to be able to do. So that when we go on to then build it, we know exactly what we're working towards. The script side is really interesting. The script is about us bringing in the conversational element, so that it's not going to be very rigid and robot-like, that we will actually write the script as if I was a user, like I did there, and I go on and I just write hi, or I have a headache. And, you know, I didn't just write headache, okay? I was using, I have personal information, so it's very conversational. So that would be all kind of thought about in our script stage. Architect is then when the design engineers would then design how it's going to look, or how it's going to play out, and look at all the different flows that might occur in terms of our conversation. Then we get to the stage of development, and with development, we talk about iteration a lot. So Corey, iteration, we hear about that a lot when we're doing coding as well, don't we?
Yes,
so,
we do.
Yeah, so we're kind of putting in code, we're testing it, we're developing it, we're going back, and we're going in cycles. So we try something out, we see where were the flaws, where things worked, where things didn't work, and we go back and we go again. So we just keep going over, and that's what's going to happen in development, a lot of coding and a lot of testing. Then when we're done with that, we then go on and we really test it, like rigidly and kind of thoroughly test it with lots of different users who maybe converse in different ways. We might use different language, not different languages, but even different ways of saying things, different kind of colloquial language that we could use. So testing it and seeing how is our chatbot responding to all of these different types of users. And finally, we deploy. So behind that bot we just trialed, okay, before that was even built, Microsoft would have gone through these stages to get to that point. So there's a lot behind it. And then we've seen when we used it, how efficiently it can work based on the setup that we've engaged with. Okay, so that's really interesting. Chatbots are cool, Corey, aren't they?
Yeah, they're so cool. And they're so helpful as well.
So helpful. So you
sometimes I don't know if it's an actual person or if it's a robot.
Yeah, and I think that's where we really can see how good the AI is, because, you know, sometimes, like Corey said, you're kind of like, is this a bot, like, or is it a human? Like, because it is very, very naturally engaging with you, okay? So for chatbots, when we're using machine learning to train chatbots, they can be done in different ways. So machine learning models could be supervised learning models or unsupervised. Now, this can be a little bit heavy, so stay with me as best you can. We are going to recap again over at the end of this and really try and make sure we understand, okay? So let's have a look at what supervised machine learning means. With supervised machine learning, what we're looking at is giving the algorithm, or training our algorithm with labeled data. And I'll explain what labeled data is in a minute. And what we're doing is we're trying to train it to a point that it gets to an outcome or result, and we should actually know what that is. So we actually have the outcome or results in our head that we want, and then we train the machine using this labeled data to get to that outcome. So we keep training it until it gets that outcome or result that we have planned for, okay? So it's very, very like supervised, very planned process, okay? Data labeling is crucial for this, okay? So for supervised machine learning, like I said, we're using training data, and that training data needs to be labeled, okay, to get that algorithm to really work efficiently towards that outcome we want. So if you look at this picture here in the image, okay, you might see that, you know, we can see as humans, we can see vans and cars and taxis and motorbikes and people, okay? But right now, this image is not labeled. So if we pass this in, if we try to train, if we use our supervised model, it's not going to really work out too well for us because we want this to be actually labeled data. The machine right now would not understand what this is. What we need to do is we need to go ahead and label it. And what labeling involves is basically just tagging it and giving it these electronic, you can see these red kind of boxes around the outside, these bounding boxes. And when we put a box around, so for example, if you look at my cursor here, this one here, so if you see this bottom car, when we put a bounding box around that, we might actually tag it then with keywords. So we might tag words like car, taxi, driving, and maybe the car make, etc. So we're able to actually, any relevant or words that are related to that image are actually included with the tag. Okay, so this is giving the machine, if we now pass this into the machine, it's really able to understand it a lot more because it has all these tags and it's labeled data this time. Okay, so what we're looking at with supervised machine learning is we get all of this raw data, and we, like we said, we have this trained and model kind of set up. We know what we're working towards. Okay, we get it labeled, we train our algorithm, and then we're able to verify, yep, that was the result I wanted. Okay, so because you know what the result you wanted is, all right? So you're really able to get to a point quite quickly then, once you have all those other steps in place, where you can verify and say, yes, this is correct. Okay, we've now used our machine, we've used machine learning to get to the final outcome we want, okay? Sometimes this can be quite a tedious process. So that labeling that I talked about, it might sound quite easy, but it's going to be quite time consuming, and depending on your data sets, that was just one image, remember. So depending on how big your data sets need to be to train your model, you might find that it's way too costly. Okay, so companies that might be doing this might not have the resources, the people or the time or the money to get this done. So what they might engage in is something we call semi-supervised learning, which is when they use some label data alongside untagged data. So they use the labeled data that they already have to coach the untagged data, and then that kind of gets them up to the point that they then need for whatever it is they're creating. So sometimes the semi-supervised approach is much more affordable for people looking at supervised machine learning. And another type then, the one that I personally can really relate to, is reinforcement learning. Okay, that's another type of supervised machine learning. And with reinforcement learning, the reason I can relate to it is because we constantly go through this as humans, okay? So basically what it is it's the idea that when we're learning something, we learn the best possible route towards the correct action or the reward that we want to reach, okay? Now this is used a lot in robotics and gaming and in navigation tools like apps for traffic and stuff like that. And basically it's trial and error. So we tried one way, if that didn't work out well, if I didn't get the outcome I wanted, if it took too long, if it was a negative experience, then I'm not going to go that route again, I'm going to go this route instead. So it adjusts itself according to these experiences. A really nice example of this is to think back to a baby. Now, we wouldn't remember this as babies, okay? But if anyone's watched a kind of younger baby at home trying to walk, for example, or try to reach a certain point. So say, for example, you have the baby in the room and their toy is the other side of the room and they're trying to walk over to that toy. The toy is the reward, okay? So they get up and they start walking. And then ultimately, when they're starting to learn to walk, they'll fall. So they probably won't reach the full side of the room straight away. And what they do is they realize, what I just did there didn't work out too well for me. I'll slightly adjust what I did, and they'll get up and they'll go again because they're trying to get to that reward. So they'll keep learning based on the experience that they're having. And that's exactly what the machine is going to do. It's going to learn based on the experience, and it's going to find the quickest route and the most efficient route to the reward it's trying to get to. It's crazy, isn't it, Corey? But it's kind of so human-like the way that works.
Yeah, it is, and it makes so much sense when you put it back into how as humans we do that. It actually makes sense.
Yeah, exactly. So with this image, you can see there's a little bit more of a cycle involved in terms of our supervised machine learning. We actually are really going back and forth because we're trying to do the trial and error to get the best possible outcome as we go. okay? And when they're talking about this, they tend to say there's three components. There's the agent, who's the learner or the decision maker. There's the environment, which is what this learner or decision maker is interacting with. And then there's the actions. So there's what is the agent actually doing, and then how does that affect the whole process, okay? So that's supervised machine learning, and that's one way actually that we can create a chatbot. But chatbots can also be used to chatbots can also be created using unsupervised machine learning as well. So this is when the machine is not familiar with the data being inputted, and generally it's not really labeled very much. There might be a couple of labeled data points, but that's kind of all it has to work with. So what it needs to do in this instance is it needs to analyze the data set and look for patterns. So it's trying to analyze different patterns across the data set based on the limited labeled data points that it does have. And what it does is it normally does something we call clustering. So it clusters them into groups. So it's finding patterns, and it goes, okay, these all have similar traits, we'll put them into that group. These all have similar traits, we'll put them into that group. So it clusters them together according to this, okay? And then once it has those clusters, it can tag them and it can keep going from there, okay? So a really kind of everyday example of this is when we have, say, for example, people in marketing, and they're looking at behaviors of people who maybe shop and buy certain products. And what they might notice is, through machine learning and analyzing customer profiles, that there's a certain trend or a certain pattern with certain types of customers. And what that does for them then in a marketing team is it means that they can then tailor their marketing campaigns towards those customers. So they're after finding out that information, clustering them, and now they can tailor their product or the experience the customer has, okay, based on that information. So it can be really useful for companies in lots of different ways. It could be used in that way. It can be used for search engine recommendations that Corey talked about earlier. There's lots of ways that this clustering approach and this unsupervised machine learning approach can be used. Okay, so that is a lot of information, Corey, isn't it?
A lot.
Yeah. So we're going to recap because I'm aware that we've done a lot there. And the reason, guys, remember we're doing this is because it should inform you that when you're ideating, and we'll go this in a second, through your projects at home, you have that knowledge behind you. You know about supervised versus unsupervised machine learning. You know the importance of data sets and all these things. So let's do a quick recap quiz here. What you guys can do at home is I'm going to pop up an explanation of these words, these keywords on the left. You can pause for a second if you want and match it up, or you might be able to do it as you're just watching. And I'm going to test Corey now, so we'll see how she gets on. So the first one we want to match up to is, this is a collection of facts, numbers, or other information, which can then be used to create or train a machine learning model.
I think it's my friend, the data set.
It is the data set, correct. So the data set, collections of facts, and remember, these are the things that we're using to create and train the machine learning model. Well done, Corey. Okay, next one. This is when labeled data is used to train an algorithm towards a set outcome or result. Corey.
Is supervised machine learning?
Very good.
Yes.
Well done. That was supervised machine learning, guys. We did at the end there. Basically, remember, we have our labeled data. It's going to be, that's our training data to get the algorithm really working towards this outcome we want. Very good. Okay. This is when sensors from a variety of devices send data to a main computer to be processed and analyzed.
And the Internet of Things?
Correct. Yeah, well done. You're flying it. IoT, the Internet of Things. Okay, very good. 3 to go. This involves marking items with electronic markings or bounding boxes and tagging them with keywords that are related and relevant to the image.
This is my favorite, data labeling.
Data labeling, yeah, you do like that one. Okay, and now we're left with a choice of 2 for this. This involves an algorithm learning based on clustering. It generally begins with a data set with only a few labeled data points.
Unsupervised machine learning.
Well done. And then obviously, guys, that leaves us with our chatbot, which was our bot that's programmed to converse with a human to help them accomplish a task. Okay, so if you even could answer those last few, or if you even kind of understand those last few points, we're flying it, because that's basically in a nutshell what we wanted to learn today. Okay, all of those different aspects that we just looked at. And like I said, remember, for your Imagine Cup Junior project, we want you to be able to put yourself in the shoes of whatever you're trying to accomplish. So if it's, for example, an AI for accessibility project, that you can actually relate to that and empathize, define the problem, and then ideate. And with ideate, hopefully the knowledge over this lesson and the next few lessons is really going to help you come up with a really concrete solution that you can then enter into your project, and no doubt do amazingly well, both in the Irish competition and the global competition, once you have that knowledge behind you. Okay, so we're going to go to Q&A. Corey, do we have any questions?
I'm just having a look through here. Nothing jumping out at me. I think just important to just for everyone at home to have a look in what we published in the Q&A maybe, and go back through the demos that we done and the AI for Good booklets.
Yeah, and if you're watching on demand, the URLs and the demos we done, you can see them happen live in the video as well. So you can just pause while we're calling out the URLs, and you can do that. That's perfect. And yeah, exactly. So just really importantly to point out, guys, that more information, and if you need to read back over this, because again, it is a lot of information for you, that we do have these student guides, and you can go and look at those student guides following the link here. So you can go and download the student guide. We've done module 1 is up there from last week, and module 2 will go up. They go into some things in a lot more in-depth information, and sometimes that's useful for people to really help their understanding of the topics. But well done on staying with us there on that one. That was a really, really hopefully informative lesson, but definitely a lot of new information for a lot of people. So if you have any questions or queries, make sure to get in touch with us at ms_edu or IRL. But we will continue then next week, and we are at our new time of 11 AM from now on. And next week will be episode 3. So until then, we'll leave you and stay safe.